Hello, everybody, and welcome to our webinar. I'm Jack Hannam, and I'm the past president of the British Society of Soil Science, and we're really delighted to be hosting this in London Climate Action Week. Thanks very much for joining us today. Before I introduce our presenters, I'd just like to introduce the Society, actually. So the British Society of Soil Science is an international membership organisation and charity, and we're committed to the study of soils in its widest aspects. So we bring together lots of different people who are working in different sectors, in academia, in industry, and we have lots of memberships growing in the practitioner space as well. So we have lots of people like implementing solutions to soil health at the interface of kind of business and industry. We also welcome anybody as a member who just has a keen interest in soil. So we welcome memberships across the board. Just before we begin, a little bit of housekeeping on the call. There's lots of you, obviously, that have joined us, but it's absolutely brilliant to see. And so your microphones have all been muted. And what we'll do is have a Q&A session right at the end after our speakers have done some introductions and some thoughts. So if you have any questions throughout the presentations, please type them in the questions box and we will return to the panel, the whole panel, towards the end of the webinar. And we've also got some CPD points. So if you are a member of any of those organisations listed on the slide there, please contact us after the webinar. And just to remind you all, we are actually recording the webinar today, and this will be available on our YouTube channel after the webinar's finished. But that's enough housekeeping. On to the exciting worlds of soils now. So next slide, please, Dom. I'd like to introduce our panelists. So we've got people represented across different parts of the sectors of soil science. We have Marcelo Galdos, and he's Programme Innovation Lead at Agrina, and he's a soil scientist specialising in digital agriculture. And through his work, he's used crop and soil and climate monitoring and modelling to assess the impacts of climate change, land use and agricultural management on yields, soil organic matter, soil moisture and nutrient use efficiency. Dr. Lizzie Sagoo is the BS president-elect, and she's Associate Managing Director at ADAS, and she has specialist knowledge in soil and nutrient management and also diffuse pollution of air and water from agricultural systems. And she's worked on lots of applied research projects, working on soil and nutrient management, so working a lot with farmers in the agricultural setting, trying to reduce things like diffuse pollution from agriculture. And finally, Dan Lambeth is a senior leader in regulatory policy and communications, and his career spans public and private sectors, including leadership roles at global institutions and advisory work on complex, high-impact issues such as sustainable finance, digital innovation, and geopolitical risk. And he has over 20 years experience in government and in the financial services industry, and most recently at JP Morgan. And there he led the firm's sustainability agenda in Europe, advising and reporting on the management of sustainability risk across all asset classes and sectors. So we've got three elements today. So next slide, please, Dom. Just to give you a bit of an idea about what the sorts of topics that we're going to be covering with our expert speakers. We're thinking specifically about looking at the climate issue, so looking at net zero goals. So what is the role of soils through carbon sequestration? Also, soils are really important in terms of providing resilient landscapes against climate or extreme events, so against things like flooding and droughts. And then we'll look at the kind of risk mitigation of all of those sorts of aspects for soils. So thinking about new opportunities that actually the finance and insurance sectors can offer to supporting the improvement of soil health. And then, as I said, we'll have a Q&A session at the end after everybody's sort of presented. So do type your questions as we go along, and we'll just finish off with a few closing remarks. But before we dive into those three aspects, I just wanted to kind of zoom back out again. I don't know if many of you are aware of soils or soil science, but around about 60% of the world's soils are actually degraded. So they're not performing all these sorts of functions that we ask of them. We ask actually quite a lot from our soils. So the main thing that people think about actually is food. Maybe you've just finished your lunch, and have a little think about the ingredients that were in your lunch. And most of those you can track back to soils in some way or another. So they're brilliant in terms of providing food, a land bank for food production, but they play a really important role in carbon storage. So Marcelo is going to expand on that a little bit later. So really important integration with the climate mitigation agenda. They also act like a big sponge as well. So although they're very thin skin on the outside of the earth, they actually can store and hold lots of water. So they're really important in terms of things like flood mitigation. There's absolutely loads of biology in soils as well. So they're not this inert thing just hanging around on the surface of the earth. They're teeming with life. And a new study recently indicated that around about nearly 60% of the global biodiversity actually resides in soil. Many people focus on all the wonderful things and the habitats and the plants that the soil supports, but it is actually a habitat in its own right. So it's doing all of these things. We demand quite a lot from them. They're really important in terms of meeting a lot of the UN Sustainable Development Goals. They also have key relevance in some of the Rio conventions as well. The obvious one being the climate UNCCC, climate change convention. So here we'll focus a little bit on, well, this is an enormous carbon store. Soils hold more carbon than the atmosphere and the plants they support combined. So they're really important in terms of climate change mitigation to be able to kind of sequester carbon from the atmosphere. They're also really important in some of the other Rio conventions. So there's a big convention on biodiversity. So as I mentioned before, soils themselves hold a huge store of biodiversity on the planet. And then finally, the UN Convention on Desertification. This system fundamentally looks at trying to reverse land degradation. So soil health plays an absolutely pivotal role in this convention. So I don't want this to become a complete lecture, but I just want to kind of like set the scene really to think about, you know, how important soils are for delivering all of these sort of functions and services, both for the environment, but also to society as a whole as well. So we're going to zoom in a little bit and focus on like three key areas now. And I'd like to introduce our first speaker, who's Marcelo. So he's going to talk us through that climate change mitigation story in terms of carbon storage in soils. So over to you, Marcelo. Thanks very much.
Thank you, Jackie, Khalid, for the invitation. It's a pleasure to be able to have this conversation, interact with the rest of the panel and people attending this webinar, eventually in the questions. So I was asked really to focus a bit on soil carbon, net zero, soil health, those links. And basically, from my standpoint, that's what I've been working on almost exclusively over the last 30 years or so. So it's a pleasure really to engage in this conversation. Can you please, yeah, pass the slide, Tom? And I was some of the questions when we were preparing this webinar came, what's the connection there, net zero and soil health? Are there practices or management systems that can actually help increase soil carbon? And what's the role of soil carbon and soil health in this whole value chain, food production, fuel, fiber, and so on? So I'll focus on those 3 points. And next, please. And to start with, I think I really like this figure from the Food and Agriculture Organization, FAO, on the ecosystem services provided by soils. And I think Jack gave a wonderful context, some wonderful context there. So I'm gonna, obviously, there's quite a few of those services that soils provide. I'll focus a bit more on the agri-environmental ones. And obviously, if you think about soil health, it is in the context, at least from one of the many definitions that are out there on how it's capable to perform certain functions, right? And when you think about agriculture, agri-environmental, and soil health and net zero, we must keep that broad picture, step back a little bit from the carbon component and think about what's the purpose actually when you think about agri environment, obviously producing something, as Jackie mentioned. So what we eat, what we wear, and fiber, and what we use of building materials, and so on. But also, the whole water dynamics and hydrology and infiltration, flood risk mitigation, but also nutrient cycling. So the circular economy, it's right connected there in this component, in this type of ecosystem, so cycling nutrients from different systems, but focusing then even a bit more on the net zero component. Basically, the main premise is that we have sources of greenhouse gas emissions that we kind of turn into CO2 equivalent, basically as a metric. So emissions, but also soils are one of the options that we have to remove some CO2 from the atmosphere and store it. Now, the whole concept of net zero works better, in my opinion, as a global system. So I take it with a grain of salt when someone tells me, this company is net zero, even, this loaf of bread is net zero. So for me, the whole concept works much better, and that's kind of the science behind greenhouse gas emissions and so on really makes sense at the global scale. So that said, we know that there are many opportunities, as Jackie mentioned as well, to improve the carbon content or to improve soil health. In that way, doing part of the work required to stay within 1.5 degrees increase in global temperatures. So it is a part of the solution, basically, but it needs to be taken in context. And there are trade-offs and synergies between those services. We need to make sure, whilst increasing soil carbon, we're not also increasing other greenhouse gases, or greenhouse gases like nitrous oxide, for example. So on the side there, you see climate regulation. So soils are really important, and methane is another very important gas that needs to be taken into account. Next, please. And I think part of the whole discussion about how do we improve the conditions, we improve soil health, improve the capacity to deliver those functions, and increase organic matter or carbon, which is a component of organic matter. We need to think about dynamic systems. And the basic concept is very simple, actually, but the application of that, it is complex. But the basic concept is we need to increase the inputs, basically, of organic material into soils that come from biomass, photosynthesis, that come from the decomposition of that biomass, even in root or root exudates, and other amendments and manure and so on. And we need to decrease how much goes out, mediated by microbial activity or disrupted, there's oxidation and so on. So it's basically the basic principle is that balance, but that's quite dynamic balance of. So the whole idea is like, let's keep more soil carbon in soils, but that's highly kind of modulated by certain soil properties, by climate, like properties like temperature and precipitation, and relative humidity and so on. So that, and then what we can control mostly, or most of the time really, is land use and management. Is how we use land. That's a crucial aspect here of net zero in this context. So we have several practices, and it's very well known, and that can be communicated as regenerative agriculture or parts of organic agriculture or sustainable agriculture, which is basically adding more organic amendments in terms of organic or organomineral fertilizers, disturbing less the soil, so tilling less, in basically, and adding more biomass to the system, more cover crops, more diverse cover crops, different root systems that actually perform different roles, and then managing the residues, the mulch, what's left, whether on the soil that can actually protect from erosion, that can actually contribute with, as it decomposes, to some of that soil carbon. Next, please. Um, and then I was asked to provide an example, and that's basically from my current role at a Danish startup called Agrina, which has one of the largest programs of its kind in Europe, probably one of the largest in the world, which basically is focused on providing incentives to farmers. I think that will tie very well to the other panelists. Uh, but also, the idea is to provide through voluntary carbon markets, but also through supply chain solutions, ways of incentivizing those practices that I mentioned previously. And it's currently in 20 countries in Europe, covering a very large area, 4.5 million hectares. And the key point here that I want to make is it is, I think, much easier to estimate or understand changes in soil carbon when we abstract a little bit and look at groups of farms or regions rather than looking at specific fields. And we don't have time to go into that, but it's very challenging to assess changes in something that is a very small fraction of the total volume or mass. Over time, that takes time and so on. But the whole idea of those combined or aggregated projects is that you could potentially detect changes that have some impact ultimately on net zero, on reducing emissions and increasing soil carbon sequestration. But that requires really a combination of technologies there, such as remote sense-based temporal and spatial assessments, new ways of kind of using machine learning and AI, and lots of measurements and how to measure that properly, new technologies in actually making it cheaper. The cost of it is still an issue. But then, just as a summary there, currently, so up to date over the last few years, and that has been going through validation by a registry, a carbon registry, close to 3 million tons of CO2 have been stored annually because of interventions that were incentivized by this program. And that's just an example, obviously. There are many other policy programs related, government, private sector, third sector, NGOs, and so on, that have the same aim, right? Improving soil health over time. Next, please. And basically, also I was asked to kind of show this component of like how do we estimate or measure changes in soil carbon, which is basically a proxy for soil health, I should say, in the whole concept of systems. Again, and the concept of systems is thinking about the life cycle assessment approach of thinking about a value chain all the way from producing the inputs that you're going to use to produce food, and that have emissions that are embedded, so embedded carbon that go into fertilizer and seeds and so on. But what happens on farm, and how do we use for nitrogen fertilizers, for example, or liming, or how much do we till, how much fuel do you use? All those are sources of emissions that can be basically decreased potentially. And also how much carbon you store over time is part of that equation. So this whole concept of trying to improve sustainability on farm, but looking at the whole value chain. As you go downstream, you have transport, you have processing, you have the consumer packaged goods, all the way retailers and the consumer all the way. So I really like this view of systems and value chains approach. And what I work on is primarily that dotted line there, what we call cradle to farm gate, but definitely that's integrated with the rest of the chain. And soil carbon should be, and I guess that's part of the society's goal as well, to expand and to highlight the importance of soil carbon throughout our society. So let's say uh, stakeholders at the far right there are starting to recognize the importance of soil health and soil carbon and work together with the ones on the left there, even fertilizer producers, but also farmers primarily, on how do we improve this whole system. Next, please. And just to close, basically those are the key points I wanted to share, right? So when we think about net zero, we need to think globally primarily, but we can act locally, obviously. But we also need to think about trade-offs and synergies. We need not only zoom into carbon, but think about net zero in the context of livelihoods, in the context of the economy, in the context of environmental sustainability beyond carbon, water, biodiversity, and so on. And I should be very clear about there's a lot of potential to increase carbon. Jackie mentioned the degradation of soils. So we have maps all over the world showing the distance where we are right now to what we can be from a biophysical perspective, from a theoretical maximum. We're nowhere near that. So there's a lot of potential to increase soil carbon in many soils and many ecosystems in the world. So it is very challenging. We need to face that, and we need to join kind of forces in terms of technology, in terms of data, in terms of capabilities to do that properly in a robust way. And as I said, it is easier when you abstract a little bit and look at groups, and that there are statistical and methodological reasons for that to detect changes over time. And finally, yeah, that is soil carbon and soil health should be at the center of discussions of sustainability and climate. Also from this perspective of the whole life cycle of what we eat, what we wear, and what we use for building materials. So that's basically what I had prepared for this talk, and looking forward to the discussion following up.
Brilliant. Yeah, thanks very much, Marcelo. We've got a few questions coming in, just to remind the audience that we'll circle back to those at the end and have a bit of a panel discussion, because I think quite a lot of those will be relevant for most of the speakers actually. But yeah, absolutely brilliant. Thinking about those trade-offs, looking beyond carbon in terms of soil health is really important. Thanks very much. Great. So I'm going to move on to our next speaker now, who's Lizzie. Soils in the context of shapes.
Perfect. Thanks, Jack. Yeah, so building on from Marcelo was talking about, I want to focus on soils and resilient landscapes. So what do we mean by resilient landscapes? So these are landscapes that are better able to withstand the shocks of climate change, and in particular extreme heat and drought, conditions similar to it at the moment, but then conversely also periods of extreme wet weather and flooding. So soil plays a crucial role in landscape resilience, as it can help buffer the impact of these types of extreme weather conditions. The two key factors that I want to focus on are soil organic matter and soil structure. Soils that have higher organic matter levels and good soil structure can better withstand the impacts of extreme weather events like droughts and floods. These soils can absorb more water during heavy rainfall, reducing runoff and flooding, and they can retain moisture during dry periods, providing a buffer against drought. However, our soils are under threat, as Jack highlighted in her introduction. Human activity is threatening the ability of our soils to deliver the ecosystem services on which we rely and to provide this landscape resilience. Over the last century, particularly since the last war, the increase in intensive farming methods, most significantly the increase in the cultivation of the soil, so mixing of the soil, and the expansion in the area of land under cultivation has damaged our soils, which means that today our landscapes are more fragile and vulnerable to the impacts of climate change. So there are a range of different threats to soils, but the three that we tend to focus on the most in the UK has kind of been the primary ones: are soil compaction, soil erosion, and loss of organic matter. And there was a study about 10 years ago by Anil Graves and colleagues at Cranfield University that estimated that together these three things, so compaction, erosion, and loss of organic matter, were costing us in England and Wales between 0.9 and 1.2 billion per year. So 20% of those costs were associated with lost agricultural production, so occurred in the field. The remaining 80% of those costs were estimated to occur off-site, so for example through increased greenhouse gas emissions, the cost of flooding and water treatment, etc. So human activity has damaged soils, but there are things that we can do to improve soil health and build that resilience back into the landscape. Next slide, please. So first, let's look at organic matter. Soil organic matter is the portion of soil composed of plant and animal materials at various stages of decomposition. Organic matter is crucial for soil health. Very broadly, on average, about 5% of soil is organic matter. So although that sounds like a small amount, it's vitally important. Organic matter is what makes soil soil. Without organic matter, it'd just be ground down rock, water, and air. It's the organic matter that gives soil that life. Soils with more organic matter can absorb and retain more water. The organic matter acts as a sponge. So this can reduce the impact of drought as the soils can hold that water, but it also reduces the risk of flooding as water moves more slowly through the landscape after periods of heavy rain. Soils with more organic matter are less susceptible to capping, compaction, and erosion. Organic matter is also the food for soil biology. Higher organic matter soils have more biological activity, greater levels of nutrient cycling and availability, which increases sort of the overall soil fertility and reduces the need for bought-in fertilizer. So organic matter is a good thing. We can build soil organic matter by adopting management practices that increase our inputs of organic matter and reduce our losses. So we can increase inputs by doing things like applying organic manures, so livestock manures, compost, etc. By increasing returns of crop residues, so by going cover crops or incorporating rather than removing crop residues, and by integrating grass or livestock into the rotation. We lose organic matter as carbon dioxide to the atmosphere and via wind and water erosion. Frequent and intensive cultivations, so that mixing of the soil, ploughing, cultivating, when we do this, it exposes the soil to the air and it encourages the breakdown of organic matter and the loss of carbon to the atmosphere as carbon dioxide. And wind and water erosion could also carry away topsoil, which is rich in organic matter, and so removing it from the field. So what we've found is continuous arable cropping with annual cultivations and little or no inputs of organic materials has led to this sort of long-term decline in soil organic matter levels in most agricultural soils. So we can reduce the losses of carbon by reducing the frequency and intensity of cultivation. So moving to reduced or no-till systems, and by trying to protect the soil surface from wind and water erosion by minimizing the time that the soil is bare and trying to make sure that we've got a crop or a cover crop growing and protecting the soil surface for as much of the year as possible. So we want to see green fields, not brown fields. But if you're looking to change a management practice to try and increase soil organic matter, we do need to understand it's a long-term process. Organic matter increases slowly over time. So these aren't quick fixes. It's about changing farming systems to protect and restore soils and the environment and build that resilience back into our landscapes. Next slide. So next, let's look at soil structure. Soil structure is a key component of soil health. When we talk about soil structure, we're referring to the arrangements of soil particles and aggregates around which roots grow and air and water move. So a good soil structure is characterized by a porous, crumbly, well-drained structure that allows free movement of air and water and encourages and promotes healthy root development. So the photos to the left here show examples of good soil structure. You can see open, porous soil structure and good root growth. Compacted soil has a poor structure. So soil compaction occurs when soil particles are pressed together, reducing the space or pores between them. And soil compaction is considered a major threat to soils. So compaction can reduce root growth as the crop roots can't get through the compacted layers. And then when this happens, then we're restricting that root growth to the top soil layers, and crop yields generally suffer because the crops are effectively growing in a much smaller volume of soil, and they're unable to access that water and the nutrients from deeper down the soil profile. So the photos to the right show compaction. The top photo clearly shows a compacted layer about plough depth, and the bottom photo shows a compacted dense topsoil. You can see that this topsoil, this compacted layer has restricted root growth of the onion crop that was growing. Now, in both of those examples, those photos, the compaction was caused by the late harvest of the previous crop in wet conditions. So soil compaction also increases the risk of soil erosion by water, because when we compact our soil, a compacted soil is unable to absorb heavy rainfall, which means that when we do get heavy rainfall, we're more likely to see the water running over the surface. And when it does that, it can cause soil erosion. So the water running over the soil surface takes some of the soil with it. So I know we're currently in a period of hot, dry weather, but next time we have heavy rain and you're walking past a ditch, a stream or a river, have a look at the colour of the water. If it looks brown and muddy, which it frequently does, it's because it's carrying soil that's been eroded from fields. Poor soil structure is generally caused by compaction from heavy machinery or livestock on wet soils. So when the soil is wet, it's less able to hold the weight of heavy machinery. So if we drive or work the soil when it's wet, we're at risk of causing and creating compaction. We can reduce the risk of compaction by not travelling or working on the soil when it's wet. But sometimes that's easier said than done. And in years when we end up with very wet autumns, it can be difficult to harvest crops, particularly late harvest root crops like potatoes and sugar beet, without causing some level of compaction. And whilst it's always better not to put compaction into soil in the first place, where compaction has occurred, it might be necessary to take action to remove it by subsoiling or cultivating to remove that compacted layer. It's important to remember that generally soils that are low in organic matter are more susceptible to compaction and soil structural degradation, and soils with higher organic matter tend to have a better soil structure and are more resilient to compaction. Next slide, please. Healthy soils also enhance plant resilience, so making our crops more capable of surviving extreme weather conditions. So well-structured soils promote good root growth and deeper root growth, and higher organic matter soils also help us retain water. And both of these are really important for resilience to drought. Some of you may have come across the term regenerative agriculture. Regenerative agriculture is a farming approach focused on restoring and enhancing the health of ecosystems and soils rather than just maintaining them. We want to regenerate rather than just sustain. It emphasises practices that improve soil health, increase biodiversity, promote resilience to climate change, and aims to reverse the damage caused by conventional farming methods. So there are 5 key principles of regenerative agriculture. These are, firstly, minimise soil disturbance. Secondly, keep the soil covered. Thirdly, maintain living roots in the soil. Fourth, diversify rotations. And fifth, integrate livestock. So the increased interest we're seeing in regenerative agriculture from across the agricultural industry shows a desire to farm in a way that improves our soil and environment and builds that resilience into our landscapes, which I think is a positive thing for all of us. Thank you. Thanks, Jack.
Thanks very much, Lizzie. And it's always very good to finish on a positive note, I think, after thinking about that kind of long-term decline in carbon stocks due to kind of intensive arable agriculture, and also the time taken to build that back as well is really important. It's not an instantaneous quick fix, is it? So yeah, thanks very much. Great. Please continue to put your questions in the question box. I will come back to them at the end after our final speaker, which is Dan. And this is really interesting to look at this through a completely different lens, actually. So he's going to be looking at kind of risk mitigation in the financial insurance sectors, looking at things like ESG. So over to you, Dan. Thanks.
Thanks very much, Jack. And if we could move to the next slide and one on again, please. I've worked in ESG finance, both on the buy side and the sell side for a number of years, and also in ESG communications. And I'm struck by just how little reference there is to soil as a commodity or an asset, and that within the finance world and comms, we're obsessed with tracking practices and processes, but we're actually not very good at valuing soil as an asset. And it struck me in preparing for the presentation that we've priced just about everything above the ground, but we've ignored the living infrastructure that's beneath our feet, which is a very peculiar situation to be in. I'd even go as far as to say that I think that soil finance, and I believe that such a thing exists, is really currently in a state of crisis, because even though it underpins so much, and we've had those 3 brilliant presentations from eminent scientists who've explained in detail why it's so important, most ESG frameworks don't specifically refer to soil, but the practices, and the EU taxonomy is a great example of that, very much focused on commercial practices, but very little, if any, reference to soil as a commodity. And we have, of course, no standardized asset class for soil, and few investors know how to actually value it. And so it's my contention that as ESG comes under pressure and given the backlash, we actually now have a fantastic opportunity to reimagine sustainable finance. And I suggest that on the basis of the evidence that we've heard this afternoon, that smart investors should start treating soil as investable infrastructure in and of itself. If we could turn to the next slide, please. So if I just break that down a bit, I think that, and as ESG investors, we're used to talking about risks and opportunities and pricing them, but I don't think that we've done a very good job of that when it comes to soil. And one of the reasons is that, as we've heard, it has multi-factor benefits. Healthy soil, it's like a sponge, it absorbs shocks from a drought and floods, and it reduces the sorts of physical risks that we think about when it comes to ESG investing and ESG ratings, but those risks in relation to soil are very rarely properly modeled. And so I think that now maybe we're getting to a point where we should be building a unified soil valuation framework, because soil obviously delivers quite multi-capital value across many different pillars, so carbon, water, resilience, yield, social equity, and we really need to find a way to bring those things together. But the problem with the current marketplace is that those systems silo those different things: carbon markets, natural capital accounts, ESG scores. They're all siloed, and they aren't brought together, which creates a very fragmented picture. Now, that's not meant in any way to criticize, for example, ESG rating agencies or investors in specific fields or areas who are trying their best. For example, I recently spoke at a soil carbon event, and the work that's being done is extraordinary. But my point is that as you listen to these scientists, you realize that there's a very wide range of impacts, both risks and opportunities, and that as financiers and communicators, we could do a better job of bringing them together. So if we can go to the next slide, please. There are green shoots. So there's some interesting developments, things like parametric insurance for regenerative agriculture, which, as you probably know, pays out on an events basis rather than a loss basis. And there's been some really interesting ecosystem risk modeling done by Swiss Re and Munich Re that I've actually used in academic research, and also some interesting soil-themed ESG funds and green bonds with reference to soil. But what we don't have at the moment is a sort of an interoperable valuation model that can look at holistically at the financial value of soil health. And also what we're not doing very well is stacking incentives. So bringing together, for example, carbon credits with insurance and tax incentives and the ESG premium. So we could do a better job, I think, of linking public subsidies, private investment, and regulatory disclosures. So I'll end with this thought. I see a lot of capital coming from whether it's family offices or major institutional investors who are looking for climate and nature solutions. But what they lack is an investable structure specifically for soil. We need to continue the good work of packaging soil products into funds, bonds, and credits. There's a lot of really good work underway, and that needs to continue, in particular blending public and private money. But I do think that there is a case for soil as a natural infrastructure product in and of itself, and its soil, interestingly, I think is one of the highest impact resilience investments per dollar. CapEx is low, and yet the returns and the multiple co-benefits, as you heard earlier, are high. So there's a plea there for this new notion of sustainable finance, and let's do the work to start, work with the scientists to start properly pricing the risks, the opportunities, and to communicate them effectively. Thanks very much.
Thanks, Dan. Brilliant. Please do put your questions in the box. I'm going to bring everybody back for the panel session now. So I'll just wait for everyone to turn their cameras on. We've had loads of questions coming in, so that's really good. Lots of interest in the themes, but there was one question that actually came in quite early that sort of links quite nicely to what you've just been discussing, actually, and I think probably many of you could probably have an answer to that. So thinking about this sort of framework and valuation. So is there actually enough data to, let's say, construct this? And for example, so one of the questions was thinking it more like a soil index, like a sort of FTSE type thing, so that you would have a kind of, a national report per country, let's say, of all of these different things. So I guess that's the question is, I guess your call to action is we should do it, but is there enough data for us to actually start to do that and actually really properly value these different aspects that we've all been talking about?
I think if you're happy for me to go first,
yeah, sure.
I think that a lot of the data is there, but what we lack is transparency, centralization, and one thing that I'm very passionate about, and that's the bridge between Lizzie, Jack, and Marcelo and the investment communities. And I think there's more work for us all to do collectively to come together to think about what reliable data looks like and to work together to build those data sets so that we have credible outcomes that can be trusted. And I do think there are some questions raised, I think, about the reliability of some of the existing investments and the MRV associated with them. And the only way we can overcome them, I think, is through partnership.
Yeah. Does anyone else want to come in with a response, or if you've got some other examples, maybe from Lizzie?
Yeah, I think in terms of is there enough data, there's lots of data, but there's also lots of challenges. So the challenge is consistency of that data and measurement of that data. So we've got data that we can compare, but we also need to remember that it's also important to monitor change over time. And we've got to view that data in the context of that particular soil. So for example, quite often we talk about organic matter, that being a key indicator of soil health. But it needs to be relative to what it was originally. If you think you might get a high organic matter content on a organomineral peat soil, but if you just look at that organic matter content, you might think, oh, that's great, but actually that could be a wasted peat soil that has degraded over time. So it's having that context and interpretation in the data that's also crucial, and it makes it's not quite as simple as a FTSE index, but I think we're making progress.
we know we don't want to make things too complicated. Everyone gets fed up of our scientists telling us
Yeah,
it's too complicated to
there's
do things,
there's
but
nothing simple about a FTSE index, Lizzie, I can tell you.
but actually links to another question there, because someone was asking, what is the kind of what would be a good value of organic matter in soil? So actually, you've kind of answered that question. Is it is very contextual. And what do we mean by that? So I'm just picking up on some of the questions here, but maybe also for you, Marcelo, as well. So you're showing some data from your example that you gave at the end of your talk, on the amount that of CO2 equivalent that's been sequestered and things. But what part of the system are you looking at? So is that just the top of the soil? Is it the whole subsoil? So the soil is three-dimensional, isn't it, as a space? So also the data and where we measure needs to then be correlated with the way that we value that, because actually we might only be looking at a small part of the system with the data sets that we have.
Yes. No, maybe two additional points there from what I think also Lizzie already highlighted, which is this context specific, is I think it's very important to look at the direction of travel, like points in, where you started from, where you're going to. And there are several programs focusing on this, like benchmarking and trying to compare similar situations or systems that you have apples and apples, but also not only specific amounts or values, because that changes a lot based on texture, how much, but also how much carbon you could store. You can't store forever or keep increasing soil carbon forever. There's stabilization processes and saturation processes as well. So it is context specific, but we know, as I think I mentioned in my talk, we have assessments over Europe, for example, showing we're very far from the potential based on climate and texture, for example. But programs looking at changes compared to similar situations and where you stand and if you're improving or not, probably much better than having hard numbers on your soil carbon should be this, and or not. Anyways.
There's a little question that's sort of linked to that around. So we talk about the data question here. There's quite a lot of questions coming in very rapidly here, so I'm trying to cover as many as I can in one question. But thinking about, obviously we can't measure everything everywhere. So you in your presentation we're looking at things like models. So how reliable are these models? Is there also so that's maybe one question for you, Marcelo and Lizzie, but also I guess the appetite in the finance space for using things like predictions and models as well as the data. So is that another risk?
Do you want me to start, Jackie?
Yeah.
Yeah, on the model component, but we know that all models are imperfect representations of reality, but they are representations of reality that should advance and evolve as our understanding evolves, scientific understanding. So there's basically strength of using modeling as a support to understand scenarios. What if? What could happen based on our best understanding of biology, physics, chemistry, agronomy, and so on. So I think there's really important uses for that. We should acknowledge the uncertainties involved, but how they could evolve, and even with the AI revolution that we're facing, how could that support better use of massive amounts of data, environmental sensors, from remote to proximal to in situ? How could we leverage that through modeling based on the sciences, But yeah, so I think there is potential, especially to look at scenarios, what if scenarios, and policy to support policy and market mechanisms, as mentioned by Dan as well. So I think there is an important role for models.
And anyone else want to pick up on?
Yeah, I'm happy to talk about appetite.
Mm.
I think there are two dimensions, and one is ESG fatigue. And I think we've just been through this extraordinary decade of a real revolution in finance and consideration of sustainability issues. But I think, given the recent backlash, perhaps the industry is pausing and thinking about the future. I know certainly from events that I've attended recently. I mean, whenever I've talked about soil finance, I've been inundated by people in the financial industry approaching me though, and actually asking about data and asking about working with scientists and the Soil Society in particular. I guess one of the issues that we need to balance is the transparency and availability of that data, though, because obviously lots of investors have their own proprietary investment models. So they're very happy to sell their own specific models that they own. And the question is how we can make those models widely available across the industry and also to public interest groups in order to better inform investment decision making and policy making.
Yeah, yeah, that's really important. Okay, great. I think I caught the end of that last session then talking about, so there are quite a lot of data on questions on data actually, and I'm trying to find a question of which I saw earlier around the types of data that sit, I guess it's picking up on your question, that sit in the in different sectors. So, and around kind of like data availability and governance of those. So between, you know, publicly collected data, so from governments, for example, where they might be collecting that data right through to sort of the individual farmer, for example. So some maybe want to discuss, are there some examples or some challenges around some of those and about integrating those in this sort of framework? Who wants to go first? Sorry, I realise you can't see me, which is a bit difficult in trying to point. Lizzie, do you want to?
I think you're right that there's lots of people collecting data and lots of different sorts of data. So the challenge is getting similar metrics publicly available. I would just note that the England Ecosystem Survey, which kicked off I think in 2024, is a big piece of government funded work that aims to collect a lot of data on soil and plant communities on a 5-year cycle. And so that going forwards could be a really useful data set for us, collecting that intensity of data, but also those repeat measures. So that's definitely one to watch in the future.
Yeah. And I guess, you know, how do we reconcile this issue then, that then a lot of that information and data that is, you know, really valuable, that she's sitting behind a paywall or, but, you know, behind some kind of restriction. I guess it's like, you know,
Yeah.
how are we able to kind of capitalize on those sorts of data sets? Are there any sorts of mechanisms that potentially we could potentially use there? Or push-pull things, or if you haven't got an answer, that's also fine. But
Yep.
I mean, maybe, you know, if there's something, I guess, it probably alludes a bit to Dan's answer to his last question, really, around, you know, different groups will have different types of models and things, but different access to different types of data sets, I guess, as well. So it's like, how how do we then develop that kind of common framework when we're looking at it through slightly different lenses?
Yeah, and I think with publicly available data sets that aren't behind a paywall, really you're often looking for government funding. You know, it's public ownership of the data and public funding to make that available. And I think that's something that's really important going forwards. Inevitably, if an organisation puts their own funds into gathering data, they want to get value from it. And that's when it becomes much harder.
Yeah, exactly. I've got some other questions.
Sorry.
Jump in. Yeah, please do.
Very quick. I think the goal should be publicly have, you know, open source publicly available. There are really, I think, leading groups doing this, and we could cite, you know, in Europe, for example, the Joint Research Center provides a lot of information based on very large surveys, such as the Lucas survey, which is publicly available. I would also mention the Open GeoHub Foundation, which is doing a remarkable job trying to bring different data sources globally, actually, on high resolution maps that are freely available. So I think that should be the direction of travel. There are many challenges towards that. I wouldn't say that's easy. And there are many regions of the world which are very, very in need of investment in that type of effort for democratizing soils data. There's definitely we need that, more of that.
Yeah, it is a key issue actually, or quite a big barrier I think at the moment to actually releasing some of these key
Although I do wonder though sometimes whether we're at risk of aiming constantly for perfection. I mean, I know that in the ESG world, there's a huge reliance on proxy data.
Yeah,
It's not possible to have all the data that we need, but we can make really smart, informed observations based on the data that is freely available. And I wonder whether scientists, I'm sorry, you probably got other questions, but maybe take it
no, it's
offline,
fine. No,
but
yeah, okay.
really interesting to think about, could we take what we have and make the best possible estimates that we could on the basis of it?
Yeah.
Good
And I
point.
think it goes back to Marcelo's point about thinking about just in the carbon story about, the direction of travel. So yes, the magnitude might be important in terms of, you might get a particular payment for particular value of things, but the direct, if you're able to indicate the direction of travel, I think that that is definitely one step further. And I think we definitely are at that point now with a combination of the data that we have, plus the sorts of models that we can use, and the applying them in the right context. So there's not a kind of broad application of these different techniques and different models, that they're kind of context specific, not down to the field, but to the sort of climate and farming and soil types that you're kind of dealing with. I think we probably, if we finish optimistically, we could probably get there at the moment with the things that we have. So great. I'm just mindful of time, so we've only got a couple of minutes left, and there's lots and lots of questions. So please do answer them yourselves as well. But there was one question, I think it was more just going back to around these sorts of, we don't focus too much on carbon, but around these trade-offs that you were talking about, Marcelo. So maybe just to finish on a bit of an example of where you're trying to kind of maximize the amount of organic matter or the amount of carbon in soils, but there have been other kind of trade-offs or knock-on effects in other parts of the system. So perhaps you can just finish on a bit of an example there.
Sure. I mean, one, I think, good example is like in a scenario in which you're able to increase organic matter or carbon in soils, but you don't change other inputs accordingly. Let's say you keep adding, let's say, crop residues and high amounts of nitrogen, synthetic nitrogen fertilizer. You have a synergistic effect, but to increase emissions actually. So you have dissolved organic carbon, you have nutrients, so you're feeding the microbes, you're throwing a lot of the inputs that they use for nitrification, denitrification. So that's a requirement. There are papers around showing this exactly. So that's the importance of context specific
Yeah,
management systems, but looking at the whole picture and adjusting nutrients, nutrient management when and that then there's a win-win. So you're also reducing upstream emissions as well when you're using nutrients better, and you're still increasing soil health and soil structure, as Lizzie mentioned as well. So yeah, that's one
great.
example.
Great. Perfect. Thank you. Good place to finish. Thinking about the whole system there actually as well. So yeah, I'd just like to, I mean, we've discussed, thanks very much to our speakers. So brilliant thinking about, big challenge from Dan there, thinking about, reimagining kind of like the ESG framework. So can we come up with this less siloed approach? So looking at the soil and it as a system, in a way, so thinking about how we value all of the components of that system, so trying to sort of de-silo those sorts of approaches as well. Thinking about again about systems approaches as well, Marcelo, I think it would be a nice place to finish on those kind of like different trade-offs. Some of them are win-win, some are not, and then finally thinking about those kind of like that building those resilience, so making sure that we're increasing soil health to rectify some of the damage that we've potentially done in the landscapes, but to look forward to kind of build resilience to those sorts of climate shocks in our systems. So yeah, thanks very much to Dan and Marcelo and Lizzie for presenting today, and the brilliant discussion. We could probably go on for another hour or so. Thanks everybody for attending and for all of your questions as well. It's been really frantic in the questions panel, but obviously shows a real big interest there. So thanks very much. Do fill in the feedback when you leave and come and visit us at the website as well. As I mentioned before, this will be available on the YouTube channel, so you can catch up on all of that as well. Just wanted to flag just before you leave a few events that we are hosting through the British Society of Soil Science. So talking about regenerative agriculture, we're going to be at Groundswell. That's it next week, and we will be there with ADAS, our corporate partner, so in the soils pit. So come and talk to us about more soil stuff. We also run a monthly webinar series as well as these ad hoc ones as well called Zoom into Soils. Next one is with one of our corporate members, Arcadis, thinking about soils and planning and construction. And those details are on our website as well. And finally, we would like to bring the whole community together towards the end of the year. So we host an annual conference. So tickets and registrations are open for that. So it'd be brilliant if you could attend that and share kind of research and policy insights. So that's going to be based in Manchester in December. And finally, we would also, so keep going, Tom. Next slide, please. We talked about our corporate members that we integrate quite a lot with a lot of the activities. So if you are interested in becoming a corporate member, just scan the QR code there. And then finally, we're doing lots of things, but talking about communication, Dan actually just appeared in our last episode of our podcast. So this is a new activity that we've been undertaking this year, and the latest one is available there. So across all platforms and also through our website. So thanks very much for attending. Some excellent questions and interactions, and hope to see you at future events. Thanks very much and bye.